Welcome back to linear algebra. Okay. Into Anki, what do we got? 6. Is it possible to get a zero matrix by multiplying two non-zero matrices? Yes. What is an invertible matrix, and what is another name for such a matrix? An invertible matrix is a matrix that exists in which another matrix exists that if you multiply this matrix by that matrix, it will be I. The resulting matrix will be equal to I, the identity matrix. And if you multiply the other matrix by this matrix, then it will be I. So A times B equals I equals B times A. Another name for such a matrix is a non-singular matrix, I believe. Yep. Ooh, did I miss something? It's a square matrix. Okay, I missed that. Square matrix that which another matrix of the same size commutes, and the product is I. Okay. How is the inverse of a product of invertible matrices related to the inverse of the individual factors? The inverse of the product equals the inverse of the individual factors, but in reverse order. What condition must be satisfied for the matrix A, B, C, D, to have an inverse? And what is that inverse in this case? A times D minus B times C must not equal 0, and the inverse in this case is 1 over AD minus BC times the matrix, which entries are D, negative B, negative C, A. Is it true in general that a matrix AB is the same? Is it not? It is not true in general that the matrix product AB is the same as the product BA. State 3 ways in which equality can fail to hold. AB and BA are different sizes. One is defined, one is not defined, and they are the same size, but the corresponding entries are not equal. Product AB is there it is, typo. AB is not, A and B is defined, B and A is not. A and B are both defined but have different sizes. A and B and A both are defined and have the same size, but the two products may be different. Good. If a linear system has infinitely many solutions, what is the general solution of that system? General solution of a system, it's a set of parametric equations in which all the solutions can be found from. Set of parametric equations from which all solutions can be obtained by assigning numerical values to the parameters. Okay, I'll say wrong just because I want to say by assigning values to the parameters. But I got the general idea right. Okay. So I'm going to grade what I did yesterday, and then we'll go from there. All right, exactly as I predicted. I got, like, the whole problem right except for a few arithmetic errors, and it's just, like, at this point, I'm actually going to count this as correct because it was a massive problem of finding an inverse and then huge matrix multiplication. It's like, I got the multiplication and the inverse correct. I just made some mistakes with arithmetic for whatever reason. So I'm going to count that overall as correct. As far as the proof goes, this was valid. Again, I could write it more formally or more precisely, which I want to learn. It's not my focus at this point. And my focus at this point is linear algebra and actually the concepts and structures of linear algebra, not formal proof writing. So I'm happy with just valid, and then both true or falses were correct. So what I'm going to do now is continue. I'm going to jump into the working with technology problem, and then if I get done with that today, I'll go through a quick second pass of this section, 1.6, which was on more linear systems and inverses, and then we're going to go and jump right into chapter 7 after that. I might just even just go. I don't know. I could just keep going. I don't know. I did do one of every problem. I might just start doing one of every type of problem. I don't know. I'll think about it. I'll talk to you in a sec. All right. We went back and did a problem from 1.2. It had some asterisks, like some unknown real numbers in a matrix, and you had to determine if it's consistent, inconsistent, and if it is consistent, how many solutions it has. It was inconsistent, I believe, pretty easily. This was the technology problem for 1.6. Basically gave it an equation stating that how to go from RGB to YIQ, which is like luminescence, percentage, chromiescence, and then chromiescence or something like that. Basically, it was like find the matrix in which you do the opposite. So this was over here was a matrix times RGB equals this. So basically what I did was take the inverse of this matrix, so it canceled out over there. Wait a second, it was on this side. It would have been like right here. That cancels, then we have the inverse of the matrix that was given, which we use the computer and MATLAB to solve very quickly. So that's that. So, yeah. Will I end up going on to 1.7 tomorrow? Maybe. Maybe I will. We got all the problems right. Right? We did a pass. We got everything right. Yeah. I think this was a fine section just to keep moving forward. And obviously we interleave problems every once in a while. Like I did a 1.2 today. So we'll come back and do more like randomly. But I'm thinking maybe it's more about keep moving forward. I've spent 100 and something days, almost 4 months, and I'm not even through chapter 1. Maybe we should move a little bit quicker. But not to say that it hasn't been worth the time. Like I've built a really solid foundation. So let's do onward. Let's do 1.7 tomorrow. So that's it for now. I will talk to you tomorrow. See ya.